So this video follows on from the previous one about forces. So we're going to introduce inertia, and we're going to talk about Newton's 3 laws of motion when it comes to forces. So just to remember, force can change the shape, speed and direction of an object. Applying a force is a push or a pull. So inertia, what's going on here? What is this? It's a car. It was traveling. The man inside the car was also traveling. Car stopped because it hit a wall, but the man kept going at the same speed. There was nothing stopping the man from, moving forward. So this is why you need to wear seatbelts, by the way. When the car stops, there was a force applied to it, but because there was no force applied to him, he will keep going at the same rate and fall out. Same idea with the truck. The truck is going forward and it's going to hit the car, and the ladder that was on the truck was also going forward, but because there was nothing stopping the ladder, it kept going. And it went on and on and on. This is called inertia. An object will keep doing what it wants to do. An object does not want to change velocity. If it's sitting at rest, it will not want to move unless you use a force. So you have to use a force to make it move. You also have to use a force to make it stop. So an object will stay at rest unless a net force moves it. An unbalanced force will move it. If the forces are balanced, of course, it will not move. They will cancel each other out. Same thing with forces the same thing with objects with constant velocity. They will stay like that until you use a force. There you go. Newton's first law. Done. An object will stay at rest or stay at constant velocity unless acted upon by an unbalanced force. So, something to think about when it comes to inertia. We have 2 buckets, an empty bucket and a bucket full of sand. Which one will have more inertia? It will be the bucket with sand, because it's got more mass. It will be harder to push this. It'll be harder to pull this. Harder to stop this. If this bucket was to accidentally hit you, it might not be too painful, but if this accidentally hits you at the same speed, it'll be a bit more painful. Okay, so inertia depends on the mass. A bigger mass has a bigger inertia. Smaller mass, smaller inertia. That leads us on to Newton's second law, which follows up from the first law. Looking at this, we have 100 newtons of force and 50 kilograms. If I have 200 newtons of force on 50 kilograms, which one will have more acceleration? Which one will speed up more? It will of course be this one with more force. So that means we can say that increasing the force will increase the acceleration. So acceleration is directly proportional to the force. Similarly, if I have 100 newtons, 50 kilograms, but 100 newtons and only 5 kilograms. Look at the mass now. Remember what we said? Smaller inertia. So that means this one here will accelerate faster because it's easier to pull a smaller mass. So that means a smaller mass is a bigger acceleration. They are inversely proportional. This means opposite. Okay, they're inversely proportional. If the mass was to increase, my acceleration will decrease. If the mass decreases, my acceleration will increase. So keep that in mind. So, acceleration depends on the force and the mass. Bigger force, bigger acceleration. Smaller mass, bigger acceleration. So, in words, you can say the acceleration is directly proportional to the force, inversely proportional to the mass. Or simply put, an unbalanced force will make an object speed up. It will make a mass accelerate. Speeding up means accelerate. That's the definition of acceleration. To put that into a formula, we have A equals F over M. If F increases, this increases. If this increases, that decreases. So this is perfect. A equals F over M. You can write it in a different way. You can write it like this. F equals MA. No problem. This is the main formula. And there's a little triangle, of course, as we did this in class. We have F at the top, M down here, and A over here. And of course, these two will multiply. This will divide with either one, depending on what the question is asking you for. Acceleration is meters per second squared, just like in the previous lessons. Force is newtons, as always, and mass is kilograms, always kilograms. So, you can also say 1 Newton is the same as 1 kilogram multiplied by meters per second squared. Otherwise, you could say kilograms meter per second squared. It's another unit. You don't really need to know it, but just in case, there it is for you. So don't forget, when we say F net, it means you have to calculate all the forces. If they're in the same direction, you will add them. Opposite direction, you will subtract them. So don't forget to do that. We have a mass of a plane of 2,000 kilograms. We have a force is 16,000. What is the acceleration? A equals F over m. Remember that? F over m. Directly substitute the number 16,000 over 2,000, 8 meters per second squared. What is the force if you have 800 kilograms and acceleration is 2? So now we have the mass and the acceleration. To find the force, F equals ma. 800 times 2, 1600 or 1600 newtons. Alright, Newton's third law. This is the final law that you need to know about. If object A puts a force on B, B will put an equal but opposite force back on A. Even if one is bigger than the other, the forces are exactly the same. So, action and reaction, equal and opposite. You push the wall will push you back. Action and reaction. You're on a skateboard, you can try this yourself. You push it, and the action is you pushing, the reaction is the wall pushing you back. Okay, action and reaction. You will move because of this. If a fly hits your window, the action is a fly hitting your window, and the reaction is the window hitting the fly back, which will be quite painful for the fly. Action. The air is getting pushed down, which means the reaction would be the balloon going upwards. The air is pushing the balloon back upwards. That's how the balloon flies away. So, Newton's third law. To every action force, there is an equal and opposite reaction force. You can write it out like this. FA on B is the same but opposite as FB on A. That's a way you can write this force. Okay, so there are some forces in this picture here. We have many forces. We could say that the elephant is pushing the rope or pulling the rope. The rope is pulling the elephant. We could say the tractor is pulling the rope and the rope is on the tractor. The rope on the man on the rope. Elephant is on the ground is pushing the elephant up. Obviously the elephant's not falling down, so that's another thing. Same with the tractor. He is floating, so he does not have anything like that. One thing to note though, even though they're equal and opposite, they do not cancel, they're not balanced. The net force is not zero, even though they're not moving, even though it looks like it's balanced. Actually, why is it not zero? Because they act on two different objects. Two different objects. What do I mean by that? Look at this. The rope has a force on the elephant. The elephant has a force on the rope. There are two different things here, the rope and the elephant. That's why you cannot technically say they are balanced, even though they look like they might be. That's it. Little summary. First law, an object will stay at rest or constant speed unless there is an unbalanced force. Second law, acceleration is directly proportional to the force and inversely proportional to the mass. A force will make a mass accelerate. That's another easier way for you to write it. If you are not very good at writing big statements, this will be good enough. Third law, every action force has an equal and opposite reaction force. And there's a little rule there for you.